You're watching the Weiss channel. Today, I'm going to talk about an introduction to graphing rational equations, and specifically, we're talking about finding holes in the graph. Okay? For example, if I'm going to graph y equals 1 over x, does it make sense that you cannot put 0 in for x? That would not work. So what if you put in 1 for x? 1 over 1 equals 1. So you're going to have a point at 1, 1 right there, right? 1, 1. What if you put in 2? If you put in 2, that makes 1/2. So 2 makes 1/2. 3 would be 1/3, 4 1/4, 5 1/5, 6 1/6, 10 1/10, right? 1,000 would be 1,000th. 10,000 would be 10,000. It will never ever get to this point here, to this line. We'll never get to 0. Okay? What if I put in 1/2? 1 divided by 1/2 is equal to 2. 1 divided by 1/3 equals 3. 1 divided by 1/4 equals 4. 1 divided by 1/5 is 5. 1 divided by 1,000th is 1,000. And it will never get to 0 here. Thus, this here is called a vertical asymptote. A vertical asymptote, where the graph will never touch this line. There's also a horizontal asymptote here. I'm going to talk about that in another video. Okay? But what I want you to understand here is that whenever you make the bottom 0, you're going to wind up with a vertical up and down asymptote. Okay? By the way, if I put in -1 for x, I get -1, -1. If I put in -2, I get -1/2, and so forth. Just the opposite of this graph. So this is the graph of y equals 1 over x. And by the way, y is the same as f of x. Y and f of x are the same thing. Okay? Here, if I say f of x or y equals 1 over x minus 1, notice it's pretty much the same graph, but this time if I put in 1, that'll make the bottom 0. So the vertical asymptote is at 1. Yes, again, there's a horizontal asymptote here, but again, I'm going to talk about that in another video. Okay, so notice that the graph, again, will not touch 0, but it also will not touch 1 here. That's a vertical asymptote. Okay, now, here's the important concept of this video. All right, look what's going to happen here. First, I'm going to factor the top. 3x squared minus 2x minus 1. I'm going to factor to 3x plus 1 times x minus 1. And when that's over x minus 1, notice that the x minus 1's cancel. So what you have is the graph of 3x minus 1, right? You have a point at 1. You go up 3 over 1, up 3 over 1, right? But here, when two items cancel, when two terms basically cancel like this, all right, you still cannot have, for example, here, x equal to 1, because that would create a denominator of 0, okay? Even though it canceled, what happens is it creates what's called a hole, okay? So when something cancels, okay, you'll have a hole as opposed to an asymptote, okay? This happens when it cancels, okay? So for my assignment today, I'm asking my students to just tell me where you're going to have a hole. right? So if you have f of x equals x plus 7, x minus 9, x plus 4 over x plus 7, x minus 4, does it make sense that the x plus 7s will cancel and the x plus 4s will cancel? Thus, x equals -7, right, will make a whole. X equals -4 will make a whole, right? That's your job today, to just tell me where the holes will be, okay? Now looking at this one, here I'm going to factor out a 5 first on the bottom. I have 5 times x squared plus x minus 12. And then I get x plus 7 over 5 times x plus 4, x minus 3. What cancels here? Nothing. So where are there holes? There are none. Your answer will just be none. Okay, sometimes there are no holes. Okay. Here, factor out a 7 on top. You get 7 times x minus 6. Factor a 3 out on the bottom. You have 3 times x squared minus 4x minus 12. Then the bottom factors to 3 times x minus 6, x plus 2. These x minus 6's cancel. So where's the hole? At x equals 6. That's your job in this assignment. You've been watching the Weiss channel.